Okay, let's take a look at analyzing radical functions now. And we'll do the same as we did in the other questions. We're going to analyze under the headings A to H that we have below, and then use that information to make a sketch. So let's first take a look at the domain. So the domain is going to be restricted by what's under the square root, right? So this has to come out positive. So what I'm going to do is I'm actually going to say, okay, 4 minus x squared has to be greater than or equal to 0. And then I'm going to proceed to solve this, right? So what I'm going to do, I'll bring the x squared over to the other side so we get this statement. And then you take the square root so that we end up with, plus or minus 2. So x is less than or equal to plus or minus 2. That actually doesn't make any sense, does it? So we actually have to do this a little bit different in this case. So in these cases, what we do is I'm actually going to say where is, it's kind of like finding your critical numbers. You're going to figure out where 4 minus x squared is equal to 0. And then we're going to test the different intervals to see whether or not it's above 0 or less than 0. Okay, so in this case, like I already kind of solved there, if you solve this, you get x is equal to positive or negative 2. So let's just make a quick little number line here and be like, okay, negative 2 and positive 2, and then just try some numbers out, right? So I can see that x, if I threw in, like, let's say negative 3, then that's going to be 4 minus, and then negative 3, that's going to come out as positive 9, right? It's 4 minus 9. That doesn't exist over here, right? So it doesn't exist over here. So just for quickness sake, I'm just going to do maybe that. And then in between, let's say, I don't know, like a number like 0. So if you threw 0 in here, that'd be 4 minus 0. That's fine. And then if you go above, you can kind of see if I threw in 3, again, none of this exists. So I'm restricted between negative 2 and 2, right? So that's my domain. So our domain here would be from negative 2 to 2. All right, moving on to intercepts. Our y-intercept is going to happen when x is equal to 0. So we'll say y is equal to, I just want to see my function again, so just throwing 0 in for my x's, so we get negative 0 times the square root of 4 minus 0 squared. So 0 times anything is just 0, so our y-intercept is at 0. So let's write that as a point just so that we're ready for it when we actually sketch it too. So that would be at the point 0, comma 0. Now let's find our x-intercept. And that's going to happen when y is 0. So we'll say 0 is equal to negative x times the square root of 4 minus x squared. All right, so what would make this true? Well, from this x, right, we'd say x is equal to 0. This is kind of like it's already in factored form, right? We're just not quite used to this square root being part of it as well. But either way, so x to be equal to 0 is one of our solutions. Now, if I look at this one, then we're really just wondering what would make 4 minus x squared equal to 0, right? Because the square root of 0 is still 0, because we want to see what makes it equal to 0, right? So then you can make a little equation, 4 minus x squared is equal to 0. And if we solve this, we just get x is equal to plus or minus 2. So there's our 3 solutions, or our 3 x-intercepts. And just because this is a long video, I think I might skip writing that out as a point like I did for the y-intercept. I think we'll be okay when we get to it. All right, so now let's look at symmetry. So for symmetry, we are going to test out f of negative x and see what we get. And then we'll be able to tell from that what type of symmetry we have. So we'll have negative, and it was supposed to be x, so I'm going to replace that with negative x, like we had there. And then times the square root of 4 minus, and then again, instead of x, we're going to substitute in negative x squared. Okay. And then from here, minus negative x, that just becomes positive x times the square root of. And just careful on this one because you might be tempted to go, okay, minus a negative here, but really we're squaring this. So this would be the same thing as just positive x, and then we're subtracting it. So this would just return to 4 minus x squared, like it was in the original, right? Now looking at that, if I compare that to my original function was f of x is negative x times root 4 minus x squared. Well, you can see that this actually is f of negative x is equal to negative f of x. And why that's true is because you can think of it as if, so if this is my f of x, right? And then if I threw a negative in front of that, well, now my negative and my negative are going to cancel, and I'm going to have my positive. Okay, so what does that mean? That means that we have odd symmetry. Okay, moving on to my asymptotes. So in this case, asymptotes are going to appear when, typically with rational functions, when you're dividing by some polynomial. In this case, we're not going to have any, right? So I left way too much room here. This should just, I can write big. I'll just say none. All right, now, areas of increase and decrease. So this is going to be a bit more happening now. So for my areas of increase and decrease, I'm interested in where the first derivative is positive and where it's negative, because if you remember, the first derivative is really just a slope, right? So if the slope is positive, it's increasing. The slope is negative, it's decreasing. So let's find the first derivative. So I think I want to write the function again, though, just so it's close. So we'll say f of x is equal to negative x times the square root of 4 minus x squared. Okay, so then f prime of x. So how should we handle this? Well, looks like we actually have to use the product rule. Like we need to actually multiply this. So think of this as my f, right? Negative x is my f, and this is my g. And that being said, maybe before I do this, then I might want to rewrite this without the radical symbol. Let's write it as negative x times 4 minus x squared, and then to the power of a half. Okay, it'll just be easier to take the derivative that way. And this was my f, and this was my g. Okay, so f prime of x, so that will be f, so negative x. Let's write that up there now, that's f, and then times, and then now I'm going to find g prime. So g prime, so looking at this one here, so I'm going to use the chain rule, so I'm going to bring the 1/2 down. So 1/2 times, and then just the inside again, so that's still going to be 4 minus x squared. And then derivative, so now we'll apply the exponent rule here and subtract 1, so this ends up being negative 1/2. And then we still have to multiply by the derivative of the inside. So that would just be, so bringing the 2 down, this is negative 2x. And then you can see I still have one more bracket to close here. So there you go. A little bit of a mess, but that is my g prime. And then we're going to add, and then I'm going to write the derivative of f. So the derivative of f, which is negative 1 times, and then just g. 4 minus x squared to the power of a half. And I'll just label that as g. Now, this is a complete mess, so let's just go to work cleaning this up a little bit. This one's actually not too bad, but this over on the left is a little bit messy, so let's write that again. So f prime of x is equal to, and then just looking through this, you can see, well, one thing here, you see I've got like this negative 2, and then I've got 1/2 over here. Why don't we just cancel that out, right? That's like 2 over 2, so those just cancel with each other, so that's nice. I also see that I have a negative, and there's a negative out front, so our negatives can just cancel, so that's nice too. So now what we're left though, I'm going to multiply my x by my other x here. So we have x squared. And then let's see what we got left here after that. So remember we canceled 1/2 with the 2 already. So we just have x squared times 4 minus x squared to the power of negative 1/2. And then I still have plus, I'm just going to take this out of the brackets. Actually, you know what? Instead of saying plus negative, let's just call that minus 4. This still has to be in brackets though. Minus 4 minus x squared to the 1/2. Now, what I'm after is I want to get this into the form, like, you know, so there's factors, right? So I don't like it that there's these two separate terms like this, right? So we can get rid of that in two ways. We can either, oh, I think I just erased a bracket. I think I can either, or we can either rewrite these as radicals and then, you know, rewrite this negative exponent in the denominator and then find a common denominator between the two terms. That would work. Like that works just fine. Another way, and actually the way I prefer, is to factor out the lowest common factor. Do you see how like 4 minus x squared shows up in both? Let's factor out the negative 1/2. Okay, so we'll say f prime of x is equal to, and then we have 4 minus x squared in brackets to the power of negative 1/2, because that's what we took out. I might make a square bracket for a second just so I don't confuse myself with the brackets. And then what we have left in this first term now is just the x squared, right? Because we took this out. So we just have x squared. And then moving on to the second term. And then just think about what we're doing there, right? When you factor something out, you're actually dividing by it. So when we had this common base of 4 minus x squared to the power of 1/2, remember how you actually just like subtract the exponents, right? We're going to do the same thing with fractions. So really, you're going 1/2 minus negative 1/2, right? Because that's what we factored out. And this is actually the same thing as 1/2 plus 1/2. So this is just 1. Well, that worked out very well because now we just have minus, and then my exponent is just 1. So this becomes 4 minus x squared. Okay, I'm almost ready. Let's you probably could at this point, maybe you can see it, but I'll just do it one more time. So now we have 4 minus x squared to the negative 1/2. What I was getting at, we could have put that to the bottom right now too, if you understood that. Be careful here because we're subtracting, you know, so the signs are going to switch. So this becomes 2x squared. They don't cancel because this becomes like plus, and then minus 4. And then now I'm going to put things where they go, right? So I'm just going to rewrite this in the denominator and keep this one up in the numerator. So we've got 2x squared minus 4 all over. And I'm going to call it the square root now too. Actually, you know what? Maybe I won't. I'm going to call it 4 minus x squared to the 1/2. And I just didn't because I'm going to use this again. I just know down below when I find the second derivative. But if you like, maybe we can write it one more time with the radical. So 2x squared minus 4 over the square root of 4 minus x squared. All right, so now let's find our critical numbers, because that's where we're going to want to check whether or not the derivative is positive or negative, right? Like on each side of those critical numbers. So we want to know where our function is equal to 0 and where it's undefined. So I'm looking at the numerator first here. So we'll say where is, so 0 is equal to, and I'm going to factor the top right now just so it's a bit more obvious. We've got 2x squared minus 2. And I'm asking where is this equal to 0? So did a little bit of algebra. We'd say x squared minus 2 is equal to 0. Rearranging this, we get x is equal to, and we take the square root of 2, right? But it's going to be positive or negative version of it. So there you go. So those are there's 2 of my critical numbers. And then the other critical numbers are going to show up when we're dividing by 0, right? So now I'm going to say, okay, where is the square root of 4 minus x squared equal to 0? And I didn't even really care about the square root, did I? Because the square root of 0 is still 0. So if you like, get rid of that. Rearranging this, we get x squared is equal to 4. So x is equal to positive or minus just 2 this time. All right, so there's my critical numbers. Okay, so I made myself a little number line. Let's kind of fill that in. So we've got our critical numbers. Doesn't really have to be accurate at all. I just need to know the numbers. Actually, this isn't going to be accurate at all. Here, let's go. Let's say 0 is right in the middle. We'll call this -2 and this +2. So then maybe √2 and -√2. Okay. So then from here, what we're interested in is whether or not the first derivative is positive or negative in these intervals. So if I look over in this interval, so f, so in this interval, so we're thinking, well, if I threw -3 into this, right? So we've got -3 squared, so that's 9. 9 times 2, bigger than -4. So this is definitely coming out positive, right? So either way, that's positive. And then the denominator, we kind of see actually a problem here, don't we? So we're going to go 4 minus -3 squared is 9. I'm getting a negative under the square root. But you know what? That actually makes sense, doesn't it? Because this wasn't even part of our domain. The graph doesn't even exist over here. So that makes sense that we're not actually getting anything with the slope of this graph, right? Or the derivative. Because this was our domain we found, right? Okay, so maybe I'll just say does not exist over here. And while we're at it, I actually know it doesn't exist over here too. So maybe does not exist over here. Okay, but then let's try a number like 1.5, right? The square root of -2 is like -1.4 something. So like 1.5, 1.6, maybe somewhere in there. So if we did that, maybe we want to write it down for this one because it's a decimal. So 2, and then if we put in, 1.6 even, squared minus 4. So my numerator here is coming out positive. And then same thing in the denominator. Actually, the denominator has to come out positive, doesn't it? Because if I have to take the square root of a positive number. So no matter what, that thing's coming out positive. So the numerator is positive. So the denominator is positive. So this thing is definitely coming out positive. So what does that mean? Well, then we know that the original function, just f of x, I'll write that below it. And you can say increasing, or I even like the visual of just like drawing like a line like that, reminding me that the real graph is going up, right? It's increasing at that point. And then, okay, so now the next interval is all the way from here to here. So I can take any point I like. Let's try 0, right? That's a nice one. So if I throw 0 in for this function, then I've got 2 times 0 minus 4, and that's -4, right? So that's coming out negative. So my derivative is negative in this region, right? Negative. So then we know that we are decreasing in this region. And then you probably see what's going to happen when we throw in a number like, again, 1.6 or something like that in between here. You know what? Now that I'm thinking about it, I think I wrote 1.6 over here, but should have been -1.6. But it didn't matter because we squared it, right? We were squaring that number. But either way, it's coming out positive. So our graph is going to be increasing. All right, so now we could write this out in interval notation, but this is already turning into a long video, so I'm just gonna note that those are my sections, right? And go with that. Now the next part, we want to figure out where the max and the min values are. So the max has to be, well, at the top of like where this thing turns around, right? So we know that that's at this interval. That's going to be our max. And this interval is going to be our minimum, right? All right, so let's find our max value. Okay, so we're going to have a max at f of negative root 2. So then if we just put negative root 2 into our original function, that would look like this. It'd be negative. And instead of an x, we have negative root 2 times the square root of 4 minus negative root 2 squared. And then if we simplify that all up, then what we get here, right? You can think of this part. This is going to come out as just 2, right? Because the negative becomes positive. The square root, if we square a square root, they cancel. So that's just 2. So we have 4 minus 2. Everything under this square root is just 2. And then you can also see these guys cancel. So what we have left here is just square root of 2 times the square root of 2. So that's just 2. Okay, so we know at this point the y value would be at 2. Okay, let's find the min. So we have f of just root 2 this time, right? Because that's where it's on its way down and then on its way back up again. This must be a minimum. So this will be negative, and then we have just filling in root 2 over 4 minus root 2 squared. So again, this would be just 2. So 4 minus 2 is root 2. Root 2 times root 2 is 2, but now there's just this negative attached to it as well. So this just becomes negative 2. So all right. We're really piecing this together. So now the last one, we have our concavity. Do this just to separate what we're doing here. So for concavity, we're interested in the second derivative, right? Because where the second derivative is positive, that means we're going to be concave up, and where it's negative, it'll be concave down. So let's work on finding the second derivative now. So it'll help to write out the first derivative. So that's why I wrote it out here. You know what? I might even go to this one. I might write it out with this style, and then I can use the product rule, right? I can multiply those guys instead of using the quotient rule. I just personally like the product rule a little more. So let's write that out. So the first derivative was f prime of x is equal to, and I'm going to write the other way too, like just like this, 2x squared minus 4, and then have my negative exponent here. So then I got 4 minus x squared to the power of negative a half. Sorry, if you can't see that is this, right? That is this one. I just swapped those two. Okay. Okay, so from there, this will be my f and this will be my g. So we're going to use the product rule here. So now f double prime of x is equal to. So now we'll do just f first. So 2x squared minus 4. And then I'm going to do g prime. So times g prime. So this would be negative 1/2. Just bring the 1/2 down times the inside. So 4 minus x squared. And then still have to take the derivative of the inside of my function. Oh, sorry. And I almost forgot my exponent. So now we have to subtract 1 from our exponent there. So we end up now with negative 3 over 2. And then we still have to multiply by the derivative of the inside. So that is negative 2x. And I still have to close one more bracket to end that bracket. All right, that's a mess. We're going to have to clean that one up. It'll be similar to last time, though. All right, and then moving on to the next one. So that'll be plus. And then I'll do the derivative of f. So in this case, that would just be 4x, right? Just derivative of f here. And then just times g. So 4 minus x squared to the power of negative a half. So again, I'm going to want to clean this up. So f double prime of x is equal to, if you like again from last time, right? I've got like a negative and I've got a negative. So those are going to cancel out and become positive. I also have a 2 over a 2 here, so those cancel. So I can cancel those right now. And I'm also going to write this x just out front, just because it'll look a little nicer. So x, and then I'm going to write this factor. So 2x squared minus 4. And we have 4 minus x squared to the power of negative 3 over 2. And then we still have plus, don't really need those brackets anymore, 4x, and then 4 minus x squared to the power of negative a half. All right, so now, like last time, we could solve for this by getting rid of my negative exponents and putting those down in the denominator and then finding a common denominator. That would work, right? But I'm going to do my same method I did last time. I'm going to take the lowest power. I'm going to factor that one out. And anything else that factors out too, because in this case, I have an x common to both, so the x will come out as well. So we'll have f double prime of x is equal to, so I'm going to factor that x out, right? This one and this one. And at this point, I'm kind of regretting it. I could have factored a 2 out of this, I'm saying too, right? But you know what? I'm going to leave it. It'll be fun. Like I think we might have to factor just something at the end, but I'll leave that for now. But just know that you could have. So anyway, I'll factor out that x. And then, like I said, yeah, we'll factor out now 4 minus x squared to the power of negative 3 over 2. And then I'm going to write what I got left. So now what we have left in this term is just this. So we've got 2x squared minus 4. And then coming over to the next one, then we have, well, we factored out the x, but we still have this 4. So we have plus 4. And then 4 minus x squared. And then remember, like I said, what we're actually doing with the exponents here. So if you need to, we can write this out somewhere else. This is really going like 1/2 with our exponent minus negative 3 over 2. So minus a negative, that's the same as adding, isn't it? So this is like negative 1/2 plus 3 over 2. So that'd be the same thing as 2 over 2. Perfect. That's the same thing as 1. So there you go. They actually got rid of my fractional exponent there. All right, so we've got x, and then hopefully you guys are okay. Can I put this down into the denominator now, right, with that negative exponent? So I will. Okay, so then x times, now I'm going to simplify this guy. So we've got 2x squared, and I can see that what I'm going to do is I'm going to go 4 times negative x squared. So this is like negative 4. So 2 minus 4. So this is negative 2x squared. And then with my constant terms, I've got 4 plus 16. So this is, or sorry, negative 4 plus 16. So this will be 12. Over, and like I said, now my negative exponent there, 4 minus x squared to the power of negative, or not negative anymore, just 3 over 2. And now, while I'm at it, remember when I should have factored out that 2 way back here? Well, here it is. I can factor it out now, right? So let's factor that out now. So here, one more time, I'll just say f double prime of x is equal to, and then I'm going to factor out negative 2. So we'll say negative 2x, and then we've still got x squared, and then this would become minus 6. All over 4 minus x squared to the power of 3 over 2. Okay, so now let's look at where our critical numbers will be. And just remember what the critical numbers are in this context with the second derivative. This is going to be, well, where our critical number, or where our second derivative is equal to 0, that's going to be an inflection point. So maybe our graph does something like this, is concave up and then concave down. So that's where our second derivative would be equal to 0, right, on our function. Or it could also be the case with like an asymptote that changes from concave up to concave down, right? Or in this case, maybe like an endpoint, because our graph starts, we know it starts at negative 2, and ends at 2. And if you think about it with our denominator here, that's what's happening here, is that if you think about the values for x, that would make this equal to 0. Well, if x was 2, 4 minus 2 squared is 4, so 0. And then same thing with negative 2 is 0. So that's really what these points are referring to, right? But it's not really going to be a concave anything on the left side of that. Okay, so from that, when we're looking at our, we'll say critical numbers. So we already figured that one out. Like I said, we'll use x is equal to plus or minus 2 just to like start and finish it, because I know it doesn't go anywhere to the left or anywhere to the right of that. And then I want to know the numerator here. So let's say, where is this thing equal to 0, right? Because that's where it would change from potentially concave down to concave up or vice versa. So let's set the numerator equal to 0. So I'll say 0 is equal to negative 2x, and then I've got x squared minus 6, right? So I can see from this factor that x would be equal to 0, so that's potentially an inflection point there, right? And then the other one here, if you rearrange this, set this equal to 0 and rearrange, we get x is equal to the square root of 6, so it would be positive or negative. But if you throw the square root of 6 into your calculator, we get x, that's supposed to be approximately, but I'm in trouble. X is like approximately equal to like plus or minus 2.4. Okay, well that doesn't actually help us, right? Because like we said, that's not even in our domain. Our graph starts at negative 2 and ends at 2. So I actually just get to kind of ignore these critical numbers. So our critical numbers so far are positive 2, negative 2, and 0. So if we like, let's make another little number line. And I'll just write down my ends of my domain here. So 2, and then 0, and then 2. And then we're just going to check in these different intervals to figure out whether we're concave up or concave down. And I don't need to check over here, and I don't need to check over here. So let's take our second derivative, okay? And we'll plug in a number like, let's do 1, right? That'd be a nice number. Put the number 1 in. And first I'll write, second derivative of x. And yeah, I said 1, so yeah, we'll do this one over here. So if I throw 1 into this function, we're going to get some negative number times 1, right? So that's negative. And then this is going to be, well, if I throw a negative into that, it's a negative 1. That'll be positive 1. Then we subtract 6. So that's coming out negative. So we got negative times a negative. That's coming out positive. And then in the denominator, we've got 4 minus, and this will be 1. So that's coming out positive. So this is going to be positive. So the second derivative, oh, not there, sorry, here. Knew I was going to confuse myself. So in that interval, the second derivative is coming out positive. So then if we throw negative 1 in there, so then that would be negative 1, that would be negative 2 times negative 1. So this section's coming out positive. And then this again will be negative because we're going to square negative 1 and then subtract 6. So that's coming out negative. And then in the bottom, we're squaring it. So it's coming out positive either way. Positive times negative is negative. So this is going to be negative. So what does that mean? That means that in between these sections, we're going to be, for f of x, this is going to be concave down. And then for in between this section, this would be concave up. All right, so our, I guess, last one here, any inflection points? Well, we kind of went through this, right? That's going to happen when our second derivative is equal to 0. So that's where we were finding where our numerator was equal to 0. So we found that happens when x is equal to 0 and then plus or minus root 6. But these ones fell outside of our domain, so they weren't really inflection points. So the only real inflection point here would be at the point f of 0 is equal to 0, which we'll say is a point of inflection. I guess therefore doesn't really make sense, but we'll say f is equal to 0, 0, and it is a point of inflection. Okay. All right, I think we're ready. I think we're ready to put this all together and make a beautiful sketch. So let's start with our, well, we know our domain is negative 2 to 2. That's as far as we're going to go. And we also know that we have x-intercepts. These are probably a good place. So we know we have a y-intercept at 0, 0. We have an x-intercept at 0. That's actually the same thing, right? It's coming from this one. But then also plus or minus 2. So it looks like our x-intercepts actually are at our domain ends. So let's draw those in now. So we know if we make our graph, make every 2 boxes maybe. So that'll be negative 1, and this will be negative 2, 1, and 2. And then I'll do the same in the y. This will be 1, 2, negative 1, and negative 2. Okay. So our function is going to start at negative 2, so that's next intercept. I'm going to color it in because I know that our domain actually includes that point as well. Okay, so there we go. And then we also have at the origin, we know it's going to go through there. And then what's next? Let's do our max and our min, maybe. So we know that we are going to have a, well, increasing and max and min here. We'll use those together. But our max point, we said, was at f of negative root 2 is at 2. So negative root 2 is roughly negative 1.4. Oh, you probably noticed that. I drew my 2 in the wrong spot. Two. There we go. That looks more symmetric there. Okay. So negative 1.4, and then that was at 2. So maybe somewhere around there is our max point. And we got something similar happening in the other direction. So then over here at like 1.4, and then we're down to negative 2 for our minimum. All right, so you can kind of see what's happening here, that we are going to be going up, passing down through the origin, and then back up again, and then just stopping right there, right? The graph doesn't exist over here or over here. And let's just check our, our point of inflection while I'm looking at it. Our point of inflection was at the origin, right? And that makes sense. We're changing from concave down at this point to concave up in this interval. Oop. Okay. And then our concavity. So we said it was going to be concave. We said it was going to be concave down between negative 2 and 0. Concave up between 0 and 2. And that is, in fact, what we see when we sketch that out. There you go. There's our sketch. And it only took us almost 40 minutes. Sorry for the long video, guys.